Hello, welcome. My name is Peter Yang, and today I will be talking about React Server Components. So just quick show of hands, how many people here have heard of server components? And first off, they are not the same as server-side rendering. But if you okay, that's good. So about half. So yeah, today I'll be showing a bit of an introduction to React Server Components if you've never heard of them before, and talk about what the motivation behind of why the React team decided to go back to the server, right? Like 20 years ago, we were rendering everything from the server. Why are we going back to the server? And I'm also going to, towards the end, talk a little bit more about how you can put these server components to work nicely with your non-JavaScript backends, right? If you're going to be using something like Next, everything can be done together in a very simple solution. Your front-end, back-end, even database access can all be done with JavaScript, of course. But a lot of companies are not using full-stack JavaScript. Many of you are probably using, some API using a different language, and that's why a lot of you end up with, a static create React app. Okay, so yeah, so that's what we're going to be talking about today. If you want to follow along, here's a link to the slides, but also what you can do is join the VS Code Live Share link. If you have a laptop, you can type that in. It'll open up VS Code in your browser, or if you have VS Code installed, you can do that. But basically, I'm going to be walking through some code, and then if you can't see it from the projector, you can follow along from your laptop, and that'll automatically follow my cursor. Okay. So let's start off by talking about a little bit of context. So I'm going to go back to think about traditional server-side rendering. So think about your PHP, Ruby on Rails, Java server pages. This is when you would have a normal backend written in Java, written in PHP, and then all you would do is you would take that data and then render that out as HTML, and it's kind of like a template before you would send it back to the users. And this was a very fast and easy way to serve content to users, right? But the thing is, adding client-side interactivity was a little difficult, right? You would have to, that was back when you'd have to use something like jQuery. You would have to fetch the data and then come back. But it worked for a really long time, and it still has very good merit because when you think about how it works, all your data is collected together on your server, and when you get sent over to the client, whoops. When it gets sent over to the client, you're really just sending HTML, and that's all pre-generated on your server. And once it gets to the user, the data is all there. There's no back and forth. The data just comes in, and it's fast. And that's why people like server-side rendering. But because of the downside of adding client-side interactivity was difficult, that's why people started moving towards client-side rendering. So this is, for example, your Create React app, Vite, basically a full experience, kind of just shifted over where there's little bits of JavaScript, and now it's all JavaScript on your front end. So you would have your API as a separate backend, so it's not like a REST API. And then now you have your front end, which is completely separate, just JavaScript only application. And it was very easy to write interactive apps. And with technologies such as client-side routing, using React Router, you could have fast page navigation, because what this meant is your entire app could be downloaded on the front end, and it could be lazy loaded, but when you click on a link, you don't have to do a full refresh of your HTML page. You could hover over the link, and you can intelligently start loading the next page, which you couldn't really do with HTML. So it felt very fast to navigate between pages, and that was great. But the downside of that is the initial load was slow, because you're bringing all this additional JavaScript to your front end, and it can become problematic, especially when you start putting in some network requests that kind of waterfall off of each other. And what I mean by this is, if you have your backend server, first, really you need to send over your HTML and your JavaScript, right? And only then can even start to go back to the server and ask for data, right? You're gonna ask for data, you're gonna make a fetch request, you're gonna do whatever, and then it comes back, right? And then you can even start rendering, whereas with server-side rendering, this three-step process all came in at once. It gets even worse when you have network requests that are dependent on each other. Imagine you have a API that gives you a list of items. First, you would have to call that list API, and then maybe if you want to get the details for each of them, maybe your API is just designed not great, so you have to make one request and then make 10 concurrent requests, right? You can imagine. Then you have to go back, make 10 requests before you even manage to come back to your client. And that can feel rather slow, because when you're talking between the client and backend server, best case, like if you live outside of a server room, like maybe you live in San Francisco, you live next to, I don't know, US West 1, AWS or whatever, that'll be like at least 10 milliseconds of connection time back and forth. But like if you're connecting from California to an Atlanta server, that could be up to like 70 milliseconds of additional latency every time you go back and forth. And that can feel really, really slow, especially on shakier connections. So because of that, React then kind of went back to server-side rendering. So we're not at server components yet, but now we have server-side rendering, which is what we started off with 20 years ago. But now we're using React to serve HTML to the user. And it was great because you still have your server-side benefits where you can get all your data together on your server and then send it over to the client, right? So that was fast. And that kind of like waterfall request I was talking about, that's acceptable on the back end because if you're making one request to like itself and just keep making those requests, you are doing this on the same computer or the same network inside the same server room. So then it's not just taking you 50 milliseconds for each request. It's taking you like less than a millisecond to talk to each other, and that's okay. And so once all this data is collected together, you would send over your initial HTML, just like how it worked with traditional server-side rendering. The only difference now is you could add in a bit of JavaScript a little easier than before because there's this process called hydration. Since you're using React on the back end, you're describing what the element tree is going to look like, and we'll send that over. And then React on the front end can take this data and basically rehydrate it and populate this, the HTML DOM elements into the React virtual DOM. So this creates a state where your HTML comes in first, as I drew here, and then you would hydrate, just hydrate on the front end, and that would like put back in the JavaScript to attach to your pre-rendered elements. And that helped a little bit. You can also do a bit of, you can also, oh, wow, okay. Oh, okay. So you can also do a little bit of progressive rendering with client-side rendering. So you might all be familiar with the previous slide where if you're doing client-side rendering, you could make your promises, make a call, wait for it, and then make another call. Then you do like if state.is loading, draw a spinner. If state.is error, draw an error, else show your data, right? You can do that all on the client side. And with React SSR and hydration, you can mix that in. So you would put a bunch of your initial data loading with server-side rendering, and then additional data then can come back with your JS data request, and then you just go back to the client. So you can kind of mix in your server-side rendering with some interactivity. But the issue is, for this progressive rendering, it still needs client-side rendering. And then if you are making those network requests, you do go back to the waterfall problem between client and server. The other downside is, this was an issue with traditional server-side rendering as well, but it comes here as well, is if you have a slow backend, let's say like it hiccups for 5 minutes and suddenly all your requests are taking 20 times longer than usual, that can result in a blank page rendering for a couple of seconds. Whereas if you're just rendering your loading spinner, you can do that with JavaScript and then you can show a spinner. But if you were starting off with server-side rendering and then your page load is being blocked by that stalled API request, you can get like a blank page for like 5 seconds. And I'm sure you've all seen this on like the internet before. Sometimes YouTube, it's great most of the time, but sometimes you click on a link, it just takes a long time for anything to happen. So that can be an issue with server-side rendering because you're waiting for your API before you can even show anything to the users. Okay, so next, next we now bring in server components, which kind of brings in the best of both worlds. So you have all the benefits of server-side rendering, and I'll talk about more on the next slide, but basically you're now able to use the server to render not just the whole page, but now individual components can be rendered on the server, and then those components can be sent to your front end and just show up whenever it's ready. There's no need to block the entire page rendering If like one API is slow, you can stream data over effectively and make the user experience a little better. You might be thinking, like, that's something I can already do with client-side rendering, but now we can do it on the server, right? We can stream data and show it progressively. There are going to be some downsides, so I'll get through some of the downsides before I talk about all the other great parts about it. There might be a little bit of a learning curve to understand, how server versus client versus shared components work. So if you're used to using only like Create React app, you're basically doing everything with a client component. And that's pretty straightforward because there's no inconsistency between what can be done on the client, except maybe your browser compatibility. But when we're introducing the server component, you have to realize we need to start thinking about code that can't necessarily run on the server on server anymore, right? So if you're doing something that calls your window object, like any window API, like window, document, or whatever, you can't get that from the server. Another thing is React Server components do not have state. It's really kind of, you think of it more like a templating language. We just put in data that gets sent as some fake form of HTML to your front end. And then additionally, you have more infrastructure requirements. If you're doing client-side apps, it's so easy to deploy. You can like spin it up on GitHub Pages for free. It scales super easily. It's very hard for you to get limited by deploying a static web app. And that's why they're still very popular. Despite their downsides, the deployment cost is very cheap and very easy to maintain. But because we have React Server components now, we need to put a server for the front end, right? You can't have a server components without a server. Now understand, like I have a server as a circle and the front end, so this is the backend server, like your API, and then your front end server as the triangle. If you were doing everything in like Next.js or whatever, you can have your backend server and front end server be the same, but my talk is kind of like, what if you don't want to use Next.js as your API server, right? So what's going to happen is like, your API will talk to the front end server, and then it can start collecting the data together. But before, as I mentioned that like you could send the data over, you don't have to wait. You can make concurrent requests. So let me try a different color. Can I? Yes. You can make concurrent requests that come over as it's ready. And I'll show a demonstration of what that looks like with a web page soon. But let's take a look at a summary of React Server components. So this is from the RFC. It was initially opened in like December of 2020. There's a link to the PR there. They've made a couple of improvements since then. But basically, this is like an abridged version of the summary. So a summary of the summary. If you want to see the full document, it's in there, and there's a lot of more useful information. But here we go. Okay, first point is that you can access server-side data sources, such as a database file system, right? Because you're on the server, you can connect to your database directly. I mean, yes, you can connect to your database directly if you expose it on the internet, but no one's going to let you do that, right? You can now securely connect it directly to your database. Maybe some of your security engineers might not like that, right? We usually want to wrap a database around, an API, but different teams do different things. The point I was trying to make across is the second bullet point is it's rendered progressively and incrementally streamed to the UI. Of the UI to the client. So let me actually pull up the bits of the code here. So I'll swipe over here. Let's see, npm run dev. Nope, that's not right. All right, yeah, so if any, that's not showing. Okay, well, I'll fix that. Localhost. Okay, so I have a demo page here on Cloud Suspense, and what's happening here is I have a page where these components are coming in one by one. And again, you might be thinking, hey, I can already do that with client-side rendering, but now I'm doing asynchronous, progressively showing data onto the client, but this is all being pushed from the server. So there's no round trip where you have to wait for the JavaScript to load, and then you ask the server back for the data, then the data goes back from the server to the client. No, this just comes from the server in like one direction. So it's there's less round trips and it's faster. So I can refresh this again, and you can take a look to see what's happening. So another cool part is that I have interactive JavaScript like ready, and it's working. Like this is your basic React demo button, like the use state count, set count, plus, right? But that's already working while we are waiting for the server to send data over. So I just have a random, so like sometime I have a random set, so some go fast, some go long, and then even show that like you can do handle promise or exceptions. So that's kind of what this demo is showing. So let me give a quick highlight of the code. Duplicate. Okay, so that's going to be inside my, what is this, suspense. Okay, so inside my suspense component, well, here's first the function for how I'm making the promises. All I'm doing is just setting a random timeout where between 0 and 10 seconds, it will either resolve or it will just, with a 30% chance, it'll reject and say, promise failed. But what I'm doing is now I'm taking advantage of the suspense component. If you're at Corey's talk earlier today, he said, you can use suspense to lazy load client-side bundles on the front end, but now we're using it to actually suspend the actual rendering of a component from the server. So what I'm setting here is I have a suspense, and the fallback is just going to be my loading animation, which is basically the same component, but instead of rendering the actual data, I just say loading. If I have but then once the timeline body is done rendering, it will not show the fallback anymore and it will show timeline body. If I take a look inside of what timeline body looks like, here is the rendering of the data. I am taking the promise in as my prop, and then I'm going to await my promise. Remember, like in current JavaScript, or in current React, you can't use await like this. This is another pretty good change, which I'll expand a little bit more, but this is a lot easier to wait on your promises. This is a promise, it could be your fetch request, it could be whatever, but I'm just waiting on that, and I'm just saying when it's done, it will return the actual rendered timeline component with the actual data in here. I have item index, format number of how long it took to resolve. And then I have a try catch, and if there's an error, then I'll render the error to the component. And that's all fine and dandy. Okay, let's see. Yeah, so because of suspense, you don't have to worry about when the component finishes rendering because you have that fallback. If I get rid of this suspense, which I can do here, well, I'll just comment it out to be easier. So if I comment it out, this will emulate what it would be like with your traditional server-side rendering, where if you had some really long API requests on your backend, it could take a long time before you even see anything. So if I open this up in a new tab, suspense. Oh, that's not correct. But out here, you see my loading spinner at the top. It's spinning, right? But remember, I said some of these requests might take up to 10 seconds. And look, nothing is happening because my server is stalled, and now they all show up at the same time, right? This is how a lot of the web works today. It will get stalled on your backend rendering. But again, if I put suspense back in, I will then simply be able to see them load as they come in. And this is a fantastic technology. Cool. Do we have any questions yet? Oh, yes, here.
So what if I don't have a current server, but during my build, I upload the assets to a CDN?
So you're saying, so you want the CDN for your static build or what?
Yeah, so upload the server-side render component, and I'm putting them up on Untitled, for example, right? And serving there instead of the current server. Does this still work?
No, you will need to have a server component. So if you want to pre-render some data, which next, that's another option you can do with Next.js. You can pull from database and render that to static HTML. That'll work, but then it's no longer connected to your server and you can't make those live requests anymore. So that does bring up a good point. Like React Server components are new, but all the other options I talked about, traditional server-side rendering, client-side rendering, server-side rendering, they all have their own use cases. There's no need to throw away your current existing app and bring in this new technology, especially if you just don't need the overhead of the server component, because really this technology just helps you like minimize the amount of loading time that the user sees, right? Internet loads pretty fast enough, right? We're doing okay with today's technology, but this just makes it a little faster because you're waiting on less data to come over the wire. Okay, let's see, display. This is duplicates, whatever, okay. Okay, so some other cool benefits is that you can dynamically choose which client components to render, which minimizes how much code you have to download. So if you imagine on the front end, like if you have a conditional rendering, so where's my new posts? I have a component here, right? If you see on line 20, what I've highlighted, basically it's checking if the user exists and is logged in, then I'll render a new post button. But if you're not logged in, then of course you shouldn't see a button because you don't have permission to do that. But on a traditional client-side rendered app, all that stuff would be included within your JavaScript bundle. But because this is a server component, what it will see is if user is falsy, like you are not logged in, it won't even send like this new post information to your client. So you're saving a bit of extra bytes there just by conditionally rendering your information. Let's see, zero impact on so it reduces your bundle size because of stuff like that. You're only sending your rendered content and not the packages you need to render it. But at the same time, you can seamlessly integrate with client components. So you can load data on the server, and then you can still use a client component for an interactive piece of information. So this right now is a server component. This is my home page. If I actually go to the home page so you can see what it looks like, here's my home page. I can sign in. And then I'll see my posts here. But this is the new post button, right? This got bubbled in as a client-side component. So most of the other stuff here is rendered by the server, but I can still put in my server client-side component because this is interactive. It pops up a modal, and then I have a form here, and then I can click submit, and then this submit is going to make a request from client-side to backend, and that's what you're used to with typical JavaScript because that's what you're going to have to do anyway if you want to have interactivity. Okay, let's see. Another cool part is client state is preserved when the server component tree is refreshed, and I kind of demoed that in my suspense demo, where when new data is coming, like the tree is constantly updating, right? Every time the promise finishes, like the tree is updated, but you'll notice like the client state here doesn't reset as I'm putting that in, and that can make a bunch of cool, useful stuff on your UI. And lastly, there's the very cool benefit that you can share code between server and client. I know I did mention some code you can't share, right? You can't use process.environment on your front end, and well, you can, but that gets statically written out at compile time. But you can't dynamically use your process.environment variables on the front end, and similarly on the back end, you can't use your window kind of stuff. But because now there is some stuff you can share, and most importantly, you can share your API request clients. So because of Node 18, we finally have fetch on the back end. Before, we've had fetch on the front end for since 2015, 2016, but now within the past year, we now have fetch on the back end. So if you write API clients, you can share that code between your front end and your back end because now fetch is cross, environment compatible now. All right, okay, a little quick talk about the whole thing about using await inside your component First off, this only works in a server component. For the client components, you can't use await. You have to use this other thing called use. I'm not really going to get too much into it because, first off, this is an RFC, and people had a less great reaction about the whole use thing on the front end, but people love the await stuff for the server components. So that's why I'm going to talk more about the await on the server components. But you all know on the client side with fetch, you use useEffect. On the server side, you would still have to do all these workarounds. Like with the Next, you use get server side props, remix, you use loader data, hydrogen, fetch sync, and even on like the original React server components demo from 2 years ago, they were like using a wrapper around the native fetch client to make it look synchronous. So you can do stuff like that, but they've decided, thankfully, to introduce first-party support for await and async functions on the back end. And it's great stuff. Okay, next. So now I want to talk a little bit about how you would integrate this with your non-JavaScript backend, because you can go on the internet and find a lot about React Server components, but they're all going to talk about using JavaScript on the backend, which is easy, but I have more time left in my talk, so I might as well make it a little more interesting. So yes, full stack development is great if you're doing it all in JavaScript. If you've seen Remix, if you've seen Next as a full stack tool, it's great, but I know a lot of you probably are not doing that. So you can instead use a combination of open source tooling to make it play nice with your existing backend. And really all we're going to do is we're going to take our server and we are going to generate Swagger types. So this is like if you're using a REST API, you generate a swagger.json, which basically represents your backend as a JSON API. And then you can convert this into TypeScript clients. Of course, you can convert it as a JavaScript client, but then that's no fun. And then these TypeScript clients will then be used both on your front-end server and your client device, because as I mentioned, fetch is now compatible both on the backend and on the, I keep wanting to say front-end, but like now front-end is front-end server and the actual client. So I should specify you can use your TypeScript clients with fetch now on your front-end server, and like the client, which we can imagine as like the user device, a phone, laptop, computer, whatever. Okay, so let me get started with more stuff in the code. All right, so the premise of this demo app is it's just a place where you can make a new post, put in some code, it'll run, and then it's really just me showing you how to render some stuff. But what I want to start off with is set up a dev container. If you're going to be working with your backend and front end, sometimes it's a little easier to have all that stuff get automated to install, right? And with npm, it's with a JavaScript project, it's easy. You run npm install, it's all there. But then maybe if you're you come in as a front end dev, you need to run the backend. You're like, oh, how do I run the backend? I don't know what to install. That's hard. So we'll use a dev container, which is basically using Docker for your containers. This might look a little daunting, right? There's a lot of config, there's some YAML, there's some stuff. This is not as hard as it seems because there's a pretty easy way to set one up. You would just need to install the dev containers extension and then open the add dev container configurations file. It's pretty easy. I'm just going to override what I have. And you'll see there's a lot of pre-configured options you can use. I have a backend here written in C#.NET, so I'm going to look for that template. And I also want a database, right? Because I need data to serve to the users. So I'm going to pick this container, which will give me .NET and Postgres. And then it'll keep walking me through a prompt, right? So I'm going to pick 6.0 for my .NET version. And then thankfully, this comes with Node.js. So I'm going to pick LTS because that's going to be on version 18. And that's what we want for having fetch. I'm also going to select a Docker and Docker. You don't need this, but there's just one specific feature I put together that I want to kind of show the power of server components. I'm going to hit OK. And then it's going to make a bunch of files. I'll just overwrite these and then immediately undo it so it doesn't mess with my configuration, but I'll show in the diff. Most of the stuff I'm using is the same, right? I just remove the comments, and then I've added a couple of extensions, right? You can actually customize what extensions get VS Code extensions get pre-installed. So anyone who runs this dev container in VS Code basically has like your same dev environment, and it's very, very helpful. Well, just to be clear, the red is because I overrode what I had set up. The red is what I added in on top of the pre-configured dev container. Another cool thing is the forward ports. So 3000 is my front end, and then 5019 is my back end. Basically, I'm saying I want these ports to be exposed from my dev container outside to my host computer so that I can access them from my browser very easily. And then I have a post create command that I created, which is basically runs all the install scripts, and that's going to be here. It's just ignore this top part. CD backend, .NET restore, .NET tool restore, that's installing the packages, and then frontend, CD frontend, and pm install. So basically, when you build the container, and then these steps run, once you launch it, you have a working environment. So what that means is if you want to go home or even go back to your hotel and play with this, all you have to do is just pull the dev container, and then everything's going to be set up. If you want to do it on your local machine, it's easy on Mac. Few extra steps to set up dev containers on Windows. I have, I think, appendix number 3 towards the bottom of my PowerPoint. If you want to look how to set up there, no, I think it's appendix 2, whatever. For even easier, if you have a GitHub account, you can go to this repo, and then click on code, and then click on code spaces. I've created a code space, so code spaces are powered by dev containers. So once you launch this code space, you'll have everything pre-configured, and you don't have to worry about the installation step. So it's very easy for you to play around with this sample on your own time. Okay, so now back to the actual content here. This is my app, and I want to show a couple of things about how to make this work. Okay, so I have a backend, and it's in C#. You might be using Java, you might be using something else, but I just chose to go with C# since it's something I'm a little more familiar with. This is a very basic API, but the important part is I'm using Swagger. Is anyone using Swagger or OpenAPI for their endpoints? Okay, yeah, so this should be familiar to most people. If you're not, I highly recommend it because, it makes it a lot easier for people to use your backend. So if I go to localhost 5019, Swagger, it'll auto-generate from your API endpoints what the inputs and the outputs are, right? So I can browse through all of these, and you'll notice it has all the schemas. So what's a post object? There's a description, which is a string, language, which is a string, that's all there. And then you'll see there's a swagger.json file. I'll open this up, and this is all represented in the JSON file. And we can take this file and then pipe it to automatically create the JavaScript or TypeScript code we need to run the stuff from our front-end server / client side. Okay, so to do that, you of course will want to look up, Swagger and then language of choice, so Swagger C#, Swagger Java, whatever, and look for a tool to generate it like so. I'm using a tool called Swagger, of course. .NET tool runs Swagger to file. I'm just going to output that as a Swagger JSON file, and you'll notice in my compile, there's going to be a Swagger JSON. And I just configure that to run every time I do a backend build. So this is always going to be available for me to generate types from. And then the next step is once I have this Swagger JSON file on my disk, I can then go to my front-end app and use another tool to generate API clients from there. So if I look at my package.json, you notice I have this script called swaggergen. Basically what I'll do is I'll call .NET build, because as I mentioned, whenever I build my backend project, it'll also output the Swagger JSON schema. And then I'll call STA, so that's an abbreviation for Swagger to TypeScript. Let's see what the package is. Yeah, Swagger TypeScript API, so this is the package I'm using. There's a lot of options for converting Swagger to TypeScript clients. This is the one I've looked at a couple. This one's the one I kind of like the most because it had a very simple API. I'm basically using most of the out-of-the-box configuration. So I'm doing output, or this is the input JSON file. Then I'll output into API client _API, which is right here. Right, you see, so this is auto-generated, and you'll notice this has, it comes with all the types I need for TypeScript. If I have the post object you saw described on the backend. Here it says description string, language string, it's all there. And then most importantly, we have like our actual utility function, so post create. We have a function I can call API.postCreate, and then I will put in my post request. It'll even tell me what data does it want to come in. And to create one, I need a description, language, and code, right? That's my input. And then, and then for my output, post create, it'll show that I'll return something. This is using templates saying the return type is post, and that's like the full data with the additional ID and the username, which get populated from the backend, right? You don't want the ID or username to be populated from the front end. You want to use username from your authentication token or whatever. Okay, so what else have we done with this API client to make it work? I've put a couple of wrappers around the API client. What I want to talk about now is a little bit about authentication and like how to make this a little more secure. So if you are using a client-side application, you're very likely taking your token and then storing that into your local storage or your session storage, which is because that's the easiest way, but that's not recommended to do because if your site is vulnerable to cross-site scripting, they could inject JavaScript code and then lift that token out from the client and send it back to their own backend for evil reasons, right? So we want to make sure this token is never exposed to to the client itself. So we'll keep it inside our front-end server, but never the client itself. So there are a couple things I had to do here. This might get easier in the future as this use case becomes more common. What I noticed because I'm using Next.js, a lot of people were complaining because Next.js does have a middleware feature where you can write your own middleware, but you can't modify the headers on your outgoing requests. So a lot of people were complaining about that, so I just had to look for some type of workaround. But the goal here is I go to my login API. I give it my username, I give it my password. It gives me back a token. Again, I don't want the token to go to the user. I want to take the token and save this as an HTTP-only cookie. So if I go to my, API, if I get the token back, here we go. What I'm going to do is I'm going to save it in a cookie. So here's the code for that right here. So I'm parsing my token from my API request. I'm going to set it into an HTTP-only cookie. And you can do some configuration for the same site, which is like if you're on a different domain, that's what that's for. And then secure is to make it HTTPS only. I have not set up an SSL cert for this demo, so I've commented that out. But if you're doing this in a production environment, you would want to do secure true to make sure you are only letting these tokens being passed back and forth on a secure environment. Okay, and basically what we do is once we have the cookie in our headers, our HTTP-only headers, we can map this to our backend where our backend accepts it as a header, like an authorization bearer header token instead of cookie. So this is the translation there, and this works for client-side requests. But we do need to do a little bit of separate handling for the server-side requests. Again, like hopefully a library will come up later to make this a little easier, but this just seemed to be one of the best ways to make this work for now if you're using your own authentication. But yeah. Okay, so this shows a little bit of concept of how I can share code between server and client, but I have to do a couple of conditionals to make sure it doesn't crash on either or. So I have this isServer function, and basically just returning top of window equals undefined, right? Because on the server, my window object's not going to exist. On the client, it will exist. And what I'm doing is, if I am on the server, if it's on the server, I will import this cookies package. Again, I cannot import this at the top of my file because it'll crash if it's loaded on the client side. So I'll conditionally load this in, and only when it's in a server condition, it will get the cookies, and then I'll take my cookie and then attach it to my bearer token when making a fetch request. Does someone have a question, or? Okay. All right, but that was the whole spiel about authentication. you just want to make sure you want to not expose your tokens to the client. But so if you are currently doing that on your client side, and then you switch to using a server-based kind of architecture, you can sell it as we're making our app more secure because now we're no longer exposing tokens to the client side. However, I will say, every time people talk about this whole, you shouldn't put your tokens in local storage because it's dangerous for cross-site scripting, I mean, you're still vulnerable to cross-site scripting even if you hide your token, because if you have cross-site scripting on your website, they can still just make a fetch request, without your permission. So like, it's safer, but it didn't, right? It's safer, but like, you're still not completely safe even by doing this. But of course, you want to be as safe as you can, even if it may or may not be futile in the future. Okay, that was a mouthful. Okay, so with that said, what this means is now I can use my API endpoints. So if I see where I use them, I have like a, let's see, API client dot instance. So I've made this as an instance, so what I can do is API client dot instance dot post create, and I can pass the data, again, with await wherever I want. Oh, well, on this case, this is a client component. So you've had to put in this use client directive. If you originally saw the first talk from 2020, they were using like filename.server.jsx and then filename.client.jsx. They decided to get rid of that, so now the convention is name your files whatever you want. By default, they'll be server components. If you want them to run on the server, you have to put this use client at the top, similar to like back then when you had to do like use script or use strict at the top of your code. It's the same concept here. But this is a client component, which I've used, which has state, and again, server components cannot have state, but client components can. And that's what I'm doing here to basically make an interactive form load on my client. And I'm calling API client.instance.post create, and that's just your normal fetch request. And again, if I want to do something from the backend, so if I have the posts page, which is here, here I'm making await API client post. So this is my get request, but this is, there's no used client at the top, which means this is a server component. I'm using the exact same API kind of instance, but you saw there's some behind the scenes stuff to make it work both front end and back end. But once that's all set up, right, it's going to be easy for you to share this API client on wherever your code is running. So I have that data, and then that gets listed out here, right? If there's no data, I'll do no post, otherwise I'll map, and that's just your normal React, right? This is something a lot of you should be familiar with. The only difference is now your data fetching can now be done with await at the top level without having to do your use effects or other workarounds that you may be familiar with. Okay. I can show one other thing here is the cool part about how I'm running code. So here's another example that shows the power of server components. I know I showed how to run code from your external API backend, but I do want to get the point across that because you're in the server, you can call into the server itself. So if you notice, I have this feature here where whenever I run the page, you have to run the code as is. And this is useful for like, I don't know, maybe if I do like, console or random, I do console.log math.random. Like I don't have to pre-compute the data. Like every time I run it, it will show the actual executed value. So if I refresh the page, the value will change each time. And you'll notice like you saw how there's that running animation where it was waiting for the data to come from the backend. Again, that's another another example of how I'm streaming data from the client, from the backend into the client as it comes. Right? I don't have to wait for that to be ready before I show the rest of my page. Again, I'll show that again. I'll refresh the page. You'll see it says running, and then the data comes in when it's ready. Right? There's like no rush. Right? Just come in when you're ready, and that's the great part about server components. With that said, because we are now running on the server, there are additional security concerns you should be aware of, especially if you're coming from a pure client-side rendered application. So if you use create React app, which I know many of you do, every time you do npx create React app, you're going to hit enter. It's going to install. At the end, it's going to say you got like 5 critical security vulnerabilities, right? right? It's scary, right? And then you're like, oh no, I've discovered something bad. You go to the GitHub page. That's like, where is it? GitHub, create React app. So I'll go here. I'm gonna say I want to report this issue. This is clearly a bad issue. We go to issues, and they literally have a pinned post saying, ignore them. That cannot be good for the sanity of our engineers. That you're being trained to see critical security vulnerabilities and then ignore them. Because now that we're going back to the server, some of these are going to start mattering, and you should start caring. And that is something you really need to consider if you are going to introduce any type of server rendering. Whether it's like React server components or even just server-side rendering, this stuff is going to start mattering. So if you want to introduce this to your team, make sure you have a contingency plan on how to audit all your packages correctly. So here's a demonstration. So if you read through this, there's a blog somewhere. Oh, here we go. regex DDoS attack. This is one that shows up a lot, and they say you can ignore it because if there's a regex vulnerability on the client, all that really does is it crashes your client, right? No big deal. On the server, it's actually bad. So under my regex DOS, so regex, so regular expression, DOS, denial of service. What this means is sometimes regex can be cool, sometimes regex can be bad. So I have a regex here. Let me show the code. I mean, regex DOS, no. Here we go, page. That's not right. I have regex here. How do you even know what this even means? But I stole this from the internet, and basically it's supposed to parse an email. If anyone tells you to use regex to parse email, ignore them. It's like the worst idea because you can end up with something like this. You end up with a regex you can't even read, and hidden in here is a vulnerability for regex denial of service. So right here, I ran on a regular email on email@example.com. That took, let me zoom in, 0.14 milliseconds, so 10% of a millisecond, okay? I make it a longer email, so like, example.com, still 10% of a millisecond. If I remove @example.com, 321 milliseconds. I went from 10% of a millisecond to what, 300 times 10, so like 3,000 times slower, like literally 3,000 times slower. If I make it, so that's like an exponential runtime, so like 2 to the n power, it can get really bad. If I add like just 10 more characters and I click that button, this will crash my server. So if I click this, right? And now I go to localhost 3000. Well, it's loading, right? Right? Your server has been denied service because you have a request that's taking up too many CPU cycles, right? And this happens. This has shown up in Lodash before, and it will show up in other libraries. So really think about the security implications if you are bringing JavaScript code into your backend environment. I mean, backend devs always have to care about this, but now you as a front-end dev also have to care about this stuff. I know, sorry. Okay, that's fine and dandy. What else do I have? Okay, so that's most of the content I do have. I can take some questions now, otherwise I will show you how to use Docker and Docker Compose just to deploy this to a production server. But any questions before that? Well, it's still running, right? Like it hasn't finished completely. Like it's dead. My server is dead. Okay. All right. Yeah. So I will literally have to pull up my process. Right. I'll try to Control C. It's like it literally won't. Yeah. So I have to kill the terminal itself, right, to make this work. I hope it comes back up. Sometimes it doesn't come back up. Yeah. Okay. I think it came back. Yeah. Right, yeah, well, maybe, who knows. Yeah, okay, there it is, right? Okay. Yeah, so we have a lot of moving parts now with the server. So if I go back to my PowerPoint, if you remember, we have more infrastructure components. We have a server, we have a front-end server, we have a client, and then what I didn't even draw was a database. So if you want a database in there as well, you gotta put in some extra stuff. Sure, why not keep these? So I just have additional Docker stuff, additional Docker components set up. So let me close all of these. And I'll show in my front end, I have a where is it? Docker file. All that does is pull from a node image, npm CI, run build, expose port 3000, and then we run that. For the backend, same thing. I have a Docker file. I pull from the .NET image, install, publish, and then expose the port. So, well, the port is default exposed to port 80, so I think you don't have to do anything for that. That runs. I combine this with the Docker Compose YAML file. What this is going to do is I build my front-end service, expose this to port 80 for HTTP. My backend, I've mapped, runs that build, and then also my database image. This is basically, the database part was copied from like the dev container, so that's more or less the same. But for my front-end and backend, I made a very short Docker file for each of them. There was like 6 lines of code for each of them, so it's not too bad. And now what I can do is run Docker Compose build. Right, like before, like if you want to configure your server, right, like you need to manually install npm and then .NET and then SQL, and then if you have more microservices, it might get a little wonkier, but we can combine all our stuff together. So yes, if you're using React Server Components, you probably will have a harder infrastructure job, right? You can't just drop it onto a S3 bucket or whatever. Do they still let you host websites on S3? Like just like does it serve JavaScript? I don't know, but like you can't just drop it on a static host and have it run anymore. But again, like the benefits are you do get a bunch of cool stuff like dynamic progressive rendering of your data from the back end to the front end. Now do be aware this is like still technically like beta, and right now it's only supported in like Next.js. The point of React Server Components is it's going to ship with a meta framework where you don't just use React by itself now. It will have to ship with React plus another actual framework. So for their beta release, they partnered with Next. So this is like, for now, the only option. There's also Shopify that had Hydrogen, but they kind of like stepped away from server components. So we'll have to see what other players come in to also serve server components for your front-end server, I suppose. But for now, Next is a great framework, so you shouldn't be too sad about having to use this as your option. All right, cool. This will just keep building, and then at some point I'll do Docker Compose up, but until then, I'll take questions. All right, no questions then. Or one here.
Has there been any case studies of doing client-side rendering versus server-side rendering in terms of like DevOps, like how is this going to affect how many servers we're going to need or how much more load on the system?
Yeah, so that's the tough part about it. We are still in, well, there's 2 parts of it. One, there's still pre-release, so not as much data. But so you kind of for now have to trust conceptually. I mean, conceptually you understand like, yes, we will need more server load. But if you think about it, we're not adding too much on top of your API layer itself, right? We're just calling your API, then pushing out a bit of HTML. HTML, it does something internally, but right, you're effectively doing HTML rendering. So there will be a bit of overhead, yes. So that's something you do want to consider. Oh, cool, my Docker thing is done. Okay, Docker Compose up. All right, well, yeah, that's, if you want to check in the repo, that's all there. But yeah, here's my production build that's been run. I can open in browser and you'll see it's all deployed. Right? I only have to run 2 commands there, right? Docker Compose build, Docker Compose up. I have a production thing set up here. I mean, minus the SSL certificate. So it's hard at first, but it can be easy if you want to use server components with your existing API backend. All right, thank you for coming to my talk. Again, there are resources here. If you want the slides, here, pya.ng/slides, and then there's a bunch of additional context at the appendices in the end. Thank you.